Hi all, good morning. Let us start with the continuation of yesterday's class. Okay, so last class we have studied about the history and development of bioprocess technology, role of bioprocess engineer, and then studied about the outlines of the integrated bioprocessing technology. And then the next topic is the unit operations involved in bioprocess. Okay, so the whole bioprocessing operations can be classified into two types, that is fermentation, product recovery, and effluent treatment. So fermentation is otherwise called as upstream, and product recovery and effluent treatment can be otherwise called as downstream. Okay, so now fermentation is a biochemical operation and can be classified as unit process. Okay, so this is a biochemical operation and then that can be classified as unit process. Okay, so and all the rest of the physical operations carried out on the fermentation broth for product recovery and downstream operations, including effluent treatment, may be classified as unit operations. Okay, so the upstream can be called as unit process. Okay, and then the upstream can be called as a unit process, and then downstream can be called as the unit operations. That means whatever the methods which have been used in the downstream method, like purification, extraction, filtration, centrifugation, extraction, okay, and then drying, all this will be called as unit operations. Understand the difference between unit process and unit operations. Whatever the steps involved in the upstream will be called as what? Unit process. And whatever the steps involved in downstream will be called as unit operations. So what will be called as unit processes? This identification of the strain of the microorganisms, then preservation of the strains, and then culturing and growing of inoculum, okay, and then pre-fermentation culturing and fermentation process, and all this will be called as what? Unit process. And what will be called as unit operation is cell disruption, okay, and then precipitation, filtration, centrifugation, liquid extraction, chromatography, ultrafiltration, drying, crystallization, and all this will be called as what? Unit operations. Okay, so that is what I have told. Upstream is being called as unit process and the downstream is being called as unit operations. Okay, so some of the other operations which have been carried out on the fermenters, such as fluid dynamics, mixing, air sparging, heat transfer, all this also can be categorized as unit operations. Okay, so the systems encountered in the product recovery and the downstream processing lines are classified as solid liquid or liquid solid or liquid solid or liquid gas and solid liquid gas and solid solid. Okay, these are all the different types of categories under which the unit operations will come under. Either it might be a solid liquid or liquid solid or liquid solid or liquid gas or solid liquid gas or solid solid. Okay, so this separation may be carried by means of phase change or without phase change also the separation may takes place. Okay, and then out of all the unit operations, mixing is one of the important unit operations which will be used in bioprocessing. Okay, and that can be between gas liquid. The mixing can be take between gas phase and liquid phase, or both should be of liquid phase or liquid solid phase, gas liquid solid phase system. Okay, and then another one important type of unit operation is the designing of impellers. Okay, designing of the various type of impellers is an important parameter in the biochemical engineering, and that is the mixing. Okay, there will be an agitator will be present, like the mixie has an impeller. Same way the fermenter also has this impeller for mixing. Okay, so the designing of this involves the unit operation. Okay, and then because depends upon this only efficient mixing will takes place. Okay, so that what happens, unit operations play an important role in this. Okay, so this is all about the unit operations. Okay, so all the upstream processing is called as unit process and all the downstream process is called as unit operations. Okay, so the different types of parameters we have studied, like solid liquid solid, and another one important one is mixing. Okay, all these are the unit operations. And the next is generalized view. Okay, so as I told, the raw materials, you will have an upstream process. Okay, this upstream process will have inoculum preparation, equipment sterilization, media formulation and sterilization, and then it will go for the bioreactor fermenter. So here you will have the reaction kinetics and bioactivity, transformation phenomena and fluid properties, and then instrumentation and control. Till this we will be calling it as what? Upstream. And the downstream you have separation, okay, and then recovery and purification, and then waste recovery and reuse of treatment. After the upstream and downstream is done, then we will go for the regulation. Okay, that means we have to get the approval of the product, that is called as what? Regulation. And then economics, okay, that is the market, and then health and safety. This is the overall view of a bioprocess. Okay, and the next topic is generalized process flow diagrams or flow sheet. Okay, this is nothing but the flow diagrams which will be used in the process engineering to indicate the general flow of plant process and equipments. For example, you take a production of ethanol, you will have so many equipments and so many parameters to be understand. Okay, so they will prepare a generalized flow diagram with the means of some representations, diagrammatic representations and all. And if you see that diagram, you will come to know what is the parameters and what and all have to be done. Okay, by seeing the flow diagram only, you will understand what are all the things happening in that particular industry. Okay, without going through the industry only, by means of seeing the flow diagram, you will understand the process which is taking place. Okay, so the typical content of this process flow diagram will be, it will show the process pipings. Okay, where and all pipings is present in the complete process, major equipment items, and then control valves and other major valves will be mentioned in the process flow diagram. And then what? Connection with other systems, major bypass recycle stream, operational data, okay, and then process stream names. All these will be present in the process flow diagram. And what and all will not be included here in this process flow diagram is pipe classes. Okay, as different types of pipes will be present. So pipe classes like piping line numbers, process control instrumentations, okay, the sensors, final control element, all these flanges, maintenance vents and drain miners, pass lines will not be mentioned in this process flow diagram. Okay, so this process flow diagram is nothing but the schematic representation of an process industry where a production is going on. Okay, so for example, this is a process flow diagram example. Okay, this is the process flow diagram which shows the unit process known as amine treating plant. Okay, this is the process flow diagram which is showing the process which is taking place in an amine treating plant. Okay, so this is a tray. Okay, so this representation denotes a fermenter. Okay, this diagrammatic representation. So this is top tray, this is bottom tray. So here you have a sour gas, this is input. So here one input, here one output. This represents the valve. Okay, and this represents the motor, and this represents the valve, and this represents the pump. Okay, this is bypass. Okay, so like that you will have a representation. Okay, this is a reflex drum pump. Okay, and lean amine. So inputs and outputs will be mentioned everywhere, and then here they will give the absorber range and all. So this is just an example how a process flow will be represented. Okay, so this is for an amine treatment plant, which is an example for chemical analysis. For example, this is an ethyl alcohol fermentation. Okay, this is for ethanol fermentation, how the process flow diagram is being understood. So this is very important. They will ask you to draw the ethanol process flow diagram of an ethanol fermentation. Okay, and they will ask you to explain that. So for example, here you have a molasses storage. Okay, and this represents the pump where from here by means of pump the molasses storage will be taken, and this represents the control valve, that is open and close or control the rate of flow. Okay, how much has to be sent, and then from there it will be sent to a continuous diluter. Okay, and from there it is being sent to a sterilizer, and from here again there is an input to the fermentation tank, and here also a control valve for closing, and here you have a yeast culture. Okay, yeast storage. So here each one will be represented by means of a representation. Storage tank is being represented by means of this parameter, and then pump is being represented by this way, and then the pump. Okay, and the diluter, so this symbol represents the diluter, and this represents a sterilizer, and this again yeast culture, and then yeast storage again wall, and this represents the fermentation tank, and this represents this chill and the extractors, all this. Okay, so like this you have a different representation which will explain you about the complete process. This is called as the process flow diagram. Okay, by means of the diagrammatic representation, you will be explaining the process of a production. Okay, that is called as the process flow diagram. Okay, that is called as the process flow diagram. And so here you just draw the things. Okay, so just not all the points has to be marked, just go through. So molasses storage is important, this fermentation, yeast culture, yeast storage. So this beer still, some 3-4 diagrams you draw and show up, suppose if the question has been asked. Same way this is for what, penicillin production. Okay, so penicillin chrysogenium, conical flask, from there it is going to the different inoculum development by means of 3 reactors. Okay, so here shaker flask, transfer vessel, sea tank, fermentation tank. Okay, rotary filter, and again first extractor, purification column, second extractor, third extractor, like that. Okay, so each company will follow a different methods of process flow diagram. Okay, so study this penicillin and this ethanol process diagram, and you have to just draw it and just explain the steps. Okay, this is how we represent the process flow diagram. Nothing technically into this. Okay, so with this the 5th module is over. So the 5th module, that problems whatever you have studied, that is stoichiometric balance. Along with that, history is very important. Okay, history of that bioprocess technology is very important. And then historical developments, and then overview and traditional application of modern. Okay, and then interdisciplinary approach of bioprocessing, that is what the outlines of various unit operations, and then unit operations in bioprocess, and then this flow diagram, process flow diagram. And these many questions are important, so I will send the OHP sheets as well as the book copy of the notes also as a PDF. Okay, thank you. And from Monday you will be having thank you, ma. From